Have you ever wondered why racing cars are so unusually shaped? Or why cyclists ride behind each other in a race? Well, inside here is a large and powerful machine that'll explain all this. Come on, it'll blow you away.
Wow, Chris, this thing is huge.
It's pretty impressive, isn't it? It's Australia's second largest wind tunnel.
So how big are we talking?
Well, we have got two sections that we test in. One's 3 metres high by 3 metres wide and 30 metres long, and we get flows of up to 120 kilometres an hour on there. And then we've got another section which is 2 metres high, 2.75 metres wide and 10 metres long, and we get flows of up to 180 kilometres in there.
Unreal. Now, what powers this? Wind power?
No, it runs off a diesel generator, but we're looking at converting it to biodiesel fuels, so it's renewable and sustainable.
And how does it all work?
We've got 6 large fans, total of 860 kilowatts of power that circulate the air through the tunnel. And then we have systems like these turning vanes to make sure that the flow is uniform where it needs to be.
Wow.
Yep, wind tunnels are impressive. But you might be thinking, what exactly are wind tunnels used for? Well, this one has various uses, right, Chris?
It does. What we're currently looking at is things like aeroacoustics, so the noise produced from wind as it travels over objects like wind turbines. We also look at environmental flow conditioning, for example, pollution distribution. Where does the exhaust gas go from all the cars when they're driving in the city? We also look at sports engineering, so we're trying to improve the performance of your track cycles or even wheelchair races to make sure that they go better. And we also look at automotive testing. For example, what we'll look at today being the Formula SAE vehicle.
This car is designed to be about half the scale of a normal race car.
We're going to be testing the aerodynamics of the car, testing if there's any drag slowing us down.
Interesting, huh? What does this button do?
Whoops.
Oh, listen, you found the wind speed dial.
Sorry about that.
That's okay. We use that to control the airflow coming down the wind tunnel, so we can adjust the speed to see how the car operates going down the straights, and especially in cornering, to see if we're increasing fuel efficiency or the car is staying along the road. So it's all set up. We're welcome to come in and start testing.
Let's get testing.
The first step to testing the aerodynamics of the car is through visualisation. But how exactly do you see wind?
So there's two different ways we see the wind. We can use smoke or we can use these wool tufts. This here is an example of where the wind is circulated and has actually tangled the string. So what we want to do is make some modifications and see if we can get this string to be straight. So we're going to retest that now. See, that's much better. The string isn't tangled anymore, which means that the air travelling over the car is much smoother. Now we're going to test the car on a corner.
Madeline makes a few last-minute checks and we're ready to go.
Am I right in saying the slipstream looked pretty good?
Yes, so the slipstream, which is the air moving over the vehicle, looked pretty good. Obviously, we can make some modifications still, so we'll take it back to the drawing board and fix it from there.
Maybe back to the drawing board for them, but how about we stick around and have some fun?